take that understanding and feed that back into technology, designing of chips in other technologies?
Well, technology is going to become more and more intelligent. I mean, all the apps, you can see that already in apps being presented here. As we move forward, they're going to be based on an understanding of the world of knowledge, particularly that we've written down. I mean, our first invention was language, so we could tell stories and tell people what happened to you today, and stories became codified. But they would drift over time, so we invented written language. And we now have computers that can store and search that written language, otherwise we could never keep track of it. But we really need to do that conceptually, to have computers actually understand those documents. And there are many different types of applications. I mentioned one at the end of my talk. But I see that's where technology is headed. Applications that will be listening into you and really understanding what you're saying. You can, I mean, a number of the demos we saw today, it'd be good to be able to actually ask for help or for the application to do something based on a natural language statement.
Can you talk a little bit about the project you're working on? You're being a little furtive on the details. But if you know, maybe one analogy is Google Glass that I think a lot of the people in the audience can relate to. We've seen a lot of publicity on it, where you have some glasses and then you have some information that pops up.
Well, Google Glass is a good example of the coming of augmented reality, and I think we'll be in augmented reality all the time. So, right now we have devices. This is too big actually because it weighs down my jacket, but it's also too small. But I walk around every day with this very large, expansive display, which is real reality, my visual field of view. That should be our display. So you can either display information, overlay it on the real world, or actually augment the real world. Just being able to be told what someone's name is, that would be very helpful. That's a killer app, which is coming. And then, of course, to give you more background about people and places and things, give you just walking directions, even in a building, but to be constantly overlaying the real world, listening in your conversation. So to build on the idea I mentioned earlier, there'd be little pop-ups. It sees you're struggling to find some name of an actress that would pop out with some background about her in a picture, and you'll just get used to this assistant helping you, and it would be second nature. But you expect this information to pop up in your visual field of view, and we'll get dependent on it very quickly. I'm already dependent on the mind expanders. We had that one-day sofa strike. I felt like a part of my mind had gone on strike. Because people didn't figure out how to get around it, but it showed the tremendous dependence we have on these brain extenders we have already.
Right. Now the Google guys, just to finish on the glass analogy, Google guys have talked for a long time about having that chip in the brain, to be able to search things you're looking for, like the name that you forgot.
Well, I don't think it'll be a chip. I mean, if you look at these are getting smaller and smaller. This 25 years from now, this will be the size of a blood cell, and there are already devices that are extremely tiny that are being put inside human bodies. Right now, it requires some kind of medical condition, although there's some that are non-invasive that you can just swallow. There are also some devices you can put in the bloodstream of animals. One cured type 1 diabetes in rats. If you go 25 years, we'll have pretty sophisticated computerized robotic devices in our blood cell. They can go inside the brain, interact non-invasively with your biological neurons, act as a gateway then to the cloud, so basically expand your brain into the cloud. And for one thing, just give you more neocortex. So why be limited to 300 million pattern recognizers? How about a billion or a trillion?
So would you be working with them? I mean, would you be working on a project in tandem with Google? Do you see them competing as platforms? Just wondering if you have a critique of what they're doing.
Well, I think Google is very well oriented towards adding intelligence search and to all of their activities. You know, they have some obvious AI projects like the driverless cars, and they have a tremendous interest in this area. It's always been my orientation not to start big companies myself, but to build the technology and then find a good home for it. So my first company, Kurzweil Computer Products, is now Nuance, which provides a lot of the technology for Siri and is a leader in speech recognition. So I do hope to create technology based on the insights that I have, not only from the book, but what we've discovered about the brain is it's using techniques that are mathematically very similar to techniques which we've used in AI, and which I actually helped pioneer in the 80s and 90s.
Right. So yeah. So Ray, you formed a company that eventually became Nuance, and then Nuance is used, just as you were saying, by Siri and I think most speech recognition companies. I think Watson is also using it, if I'm not mistaken. Siri has been criticized by some to be a little slow, not perfect. Some people have given up on it. Can you talk about where that's going, and maybe critique where you see the current technology and perhaps uses to advance that somehow?
Well, I think actually the natural language understanding in Siri is fairly weak. That needs a lot of improvement. I think that's feasible. I think some of the ideas I'm pursuing will provide that. I just think it's interesting as a threshold. Actually, for a version 1 product, it's pretty good. Because usually version 1 doesn't work at all. And people do still use Siri.
You said you're pursuing natural language technology
to
improve that?
Yeah.
Is the brain growing over time? I mean, can you talk a little bit about, you were just referring to how you were limited. You felt like you take an hour to read a book, and that's really frustrating, right? How can we augment our brain? I'm just wondering, is it growing over time? What are the things we can do to augment?
Well, it actually doesn't grow much from a very young age. There are what I call, there are these modules that are these 300 million pattern recognizers. There's interesting research that shows the connections inside one of these modules, which I estimate about 100 neurons, is stable and doesn't change. It's the connections between the modules that evolve. And we pretty much have those 300 million at a very young age. One of the reasons that kids can learn languages or learn anything, music, so quickly and readily is they've not filled up those 300 million pattern recognizers with concepts. And so it's virgin territory to absorb all of these insights. A key thing is by the time we're at even 20, we've filled it up. We need to be able to intelligently and selectively destroy information to learn new information. And we need to be able to repurpose our neocortex to learn something new. People who have a rigid process for holding on to old information and not being willing to accept new information are going to have difficulty doing that. But I think actually at any age you can learn new material, even as quickly as a child. But you have to be able to kind of move on. Now there's a dynamic process. You don't have to completely unlearn something. You can keep a certain amount of it. There's a lot of redundancy. You can reduce the redundancy and learn new material. But there is a limited capacity. And I think ultimately that's one of the things we're going to overcome by basically expanding our brains into the cloud.
Can you talk a little bit about that, expanding your brains into the cloud? Because that's something I'm sure a lot of people would like. If Einstein could have expanded his brain and done a lot more than just science. You've talked about how he was a violinist, but he could play the violin, but he wasn't a violinist. So you could do anything you wanted to do.
Well, we already have profound brain extenders. Just the fact that we can search all of human knowledge. And search engines are already, quite impressive and have codified knowledge in databases like Wikipedia and all of the myriad other brain extenders we have is fantastic. We are smarter. I've been managing work groups for 45 years, and I can have a group of 3 or 4 people do something in 3 weeks, which used to take 50 people 3 years. I can see that. I can see it in myself as I write books and the process I used to have to go through. As they get more intelligent, that's good. That's type of brain expansion, even if it's not physically inside my body and brain, it's going to get more and more sophisticated. I think that's an arbitrary distinction whether to put something inside or not. But ultimately, it will go inside. We will expand these 300 million pattern recognizers because we will be able to actually recreate them functionally to do exactly what they do in our brain and learn. And quantity results in a different quality. So a ape or a chimpanzee is close to a human, but doesn't have as much neocortex as we do, particularly because of our frontal cortex. That additional quantity resulted in the qualitative leap of philosophy and language and art and science and technology. So when we expand it again, which is what I think we will do, we can't even describe what that next qualitative leap will be. I mean, how could somebody without language describe what the world of language would be like? And so we're going to make qualitative leaps by being able to expand our neocortex. And we'll do it directly from the brain. And it will be in the cloud because that's where all interesting things happen. I mean, if you use a mobile device to translate, to search for something like Siri, it's not done in the phone, it's done out in the cloud. So that's, we will expand our brains into the cloud.
Great. So, yeah, you were saying earlier that you couldn't do certain things in 2002 because you needed the machines in 2012 to be able to do them. I wanted to ask you a question on behalf of the entrepreneurs in the room. In your view, since your brain, I presume, is limited and you can only do a few of these cool projects, what are the empty spaces that we can work on that maybe in 2012 that we can begin to go work on to as entrepreneurs to go create value and to build companies? I'm just wondering what.
I think something that is coming is an ability. There's been a lot of discussion of big data, but big data is not just numerical tables or alphanumeric tables. Most of the interesting information is natural language that exists on Facebook pages and on blogs, and not to mention all the more organized material like encyclopedias and the ability to actually understand the page, even if it's not quite at human levels, and that we won't get to until 2029, because that's the Turing test, and that's been my date. And, there's reasons actually to be optimistic and say maybe it'll happen sooner, but I haven't officially changed that position. But what I think we will have over the next few years is the ability to get meaningful information from natural language documents. That's more than just playing tricks with whether or not there's certain words in proximity with each other. To actually get into the semantic structure of natural language documents. And that, many of the applications that are discussed here could benefit from some intelligent understanding of natural language.
Can you explain why it's going to take so long? We've seen these efforts time and again. We saw a company called PowerSet 3 or 4 years ago that tried to say that they could do semantics natural language search. They were bought by Microsoft. A lot of people were laughing at their claims that they could do this. They solved the riddle. And they were saying, well, they actually had made some progress. Why is it going to take so long to do so?
Well, I didn't see natural language understanding technology from PowerSet. They had some things that could do tricks with summarizing documents by doing sort of certain analyses of where long words were, and you really have to approach it the way the human brain approaches, with a hierarchical approach. And language is hierarchical, just like the human brain, which is no coincidence, because the human brain created language. It was our first technology, our first invention. And it reflects very much the structure of the neocortex, and you have to build it that way. And a key part of the technology is learning. Even if you did a perfect job of functionally simulating the neocortex, it wouldn't do anything unless you educated it. Just like a newborn, does have evolutionary ability to be very cute, which is a survival instinct, but you know, it's not going to hold a conversation with you. And it learns concepts one layer at a time. And it's got to lay down a whole layer of understandings, say, of primitive shapes and sounds, and then it can do the next layer. And as adults, we do that too. We have to learn certain prerequisites till we can learn the next layer of science or technology. And we're going to have to educate these synthetic neocortexes the same way. Now, we don't have to take 20 years. We can speed up that process. But that's not incidental. I mean, that is core. I mean, just as we focus on education for humans, we're going to have to focus on education for these synthetic neocortexes. We can't just let it loose on hundreds of millions of pages. But they did do that with Watson and got it up to a point where it does a subhuman level, but it can then combine that level of understanding with a tremendous scale and speed and total recall of computers. Because then it can take that understanding and actually apply it consistently to 200 million pages of documents.
I've got a final question for you. We're unfortunately out of time. Ethics. Some people have argued that there's been no progress at all in human civilization despite our massive amounts of knowledge. Others have argued that there is progress, that somehow we have advanced as humans. What is with your understanding of where the brain is going, how about ethics in terms of
There's two big questions there, which we could take a whole conference on each one. But
we got 1 minute.
Yeah. I would certainly say we have made progress, thanks to communication technologies. It started with things like the printing press, and the printing press and the kind of early spread of democracy happened around at the same time. And we now see the democratic impact of social networks like Facebook. And, so it's a long discussion, but I would say that human beings, being assisted by our ever-increasing and exponentially growing communication technologies, have become more democratic and more representative of the values which this country celebrates. There is an issue, kind of a different issue in AI, which is the whole friendly versus unfriendly AI issue. Technology has always been a double-edged sword. I mean, is fire a good thing? It kept us warm, it cooks our food, it was also used to burn down our villages. Technology has been a double-edged sword ever since fire and stone tools and the wheel. AI can also be dangerous. There are plenty of science futurism movies that make that point. Usually, I think the fallacy in those movies is that the AI is out there and it's someone else, something else. What I see already is that AI is very widely distributed. And it's not just in some dark lab of a government somewhere. A kid in Africa with a smartphone has access to more intelligent information than the President of the United States did 15 years ago. It's a very empowering capability to democratize creativity. So a kid in Africa, and certainly millions of people here, can create technologies and come to this conference and demo them. But it can also be used for destructive purposes. If you have an AI that's more intelligent than you are and it's meant for your destruction, that's a bad situation to be in. And the only way you can protect yourself would be to get some AI allied with you that's more intelligent than it. And if it turns on you, well, then you need to get even smarter AI. There are answers to this. I mean, this is actually not a specter today in AI, but it is a specter today in biotech. The same technologies we're using to reprogram biology away from cancer and disease could be used by bioterrorists right today to reprogram a virus like flu or the cold to be more deadly, more communicable, and create a super weapon. I've actually worked with the U.S. Army on developing a rapid response system for that. That's one in a broad category of ways to deal with it. Having ethical guidelines to prevent abuse, which we have called the Asilomar guidelines, is another approach. So it's a more complicated issue that we can describe in 1 minute, but I think between ethical standards and rapid response systems to identify dangers is the answer. And we can take, I think, comfort from how well we've done with one kind of evolving threat, which is software viruses. Software viruses have gotten more and more sophisticated, and nobody can cross them off our list and say, oh, well, software viruses, that's not a problem anymore. But it hasn't shut down the internet. Nobody says, well, the problem is so bad, let's just scrap all computers and start over. We clearly get far more benefit than harm. And we have an evolving technological immune system that's been able to keep up with the problem, more or less. You can have arguments about it, but I think it's basically working. That's a prototype for how we need to deal with these issues.
Great. Thank you, Ray. I will not ask you about intelligence in space. Thank you very much, Ray.